Hi students, today I am going to introduce a new concept in calculus. See, in previous classes in PU and other classes, you studied the concept of limits. So, limit of a function. So, first I would like to discuss one problem on limits. Yes, first, so let us evaluate this. Evaluate limit of limit of you take it is x square minus 9 by x minus 3. So when x tends to 3. As here, to evaluate this limit, so you take that. Yeah, it is very familiar problem. You already studied in PUC and other classes. Okay. So let k is equal to, you take this limit is k is equal to limit x tends to 3. It is x square minus 9 by x minus 3, which is equal to, you just apply the limit, it is 3 square minus 9 by 3 minus 3. Yes, all of you know that 3 square is 9, 9 minus 9 is 0, and 3 minus 3 is 0. So when it appears 0 by 0, so we are using some other method to solve this one. We are using some other methods. Okay, so what that method is? So when we are getting that 0 by 0, so we are using some other method, that is we are writing that k is equal to limit x tends to 3. So this 3 square x square minus 9 can be written as x square minus 3 square, x square minus 3 square by x minus 3, which is equal to limit x tends to 3. X square minus 3 square, it is like a square minus b square. A square minus b square can be written as a minus b into a plus b. So right, this is a plus b, so that is x plus 3. Okay, sorry, this is x plus 3 into x minus 3 divided by x minus 3. So here x minus 3 cancel with x minus 3. This is x plus 3. Okay, right, it is limit x tends to 3 is x plus 3. So when you are applying the limit to this x plus 3, it is 3 plus 3 is equal to 6. So the limit value of this is equal to 6. So actually, so this is one of the method of evaluating the limits. Whenever it appears 0 by 0, infinity by infinity. So in that problems, we are using some more different methods to evaluate that type of integrals. Okay, that type of limits. Okay. So these forms, when we are applying this limit, when it appears 0 by 0, so this forms, that 0 by 0 form, this form is called indeterminate form. So that means still we are not determinate that value. Okay, that is indeterminate form. So it is indeterminate form. So not only this, if it when we are applying the limit, when it appears infinity by infinity, that is also indeterminate form. Infinity minus infinity, infinity to the power of infinity, 1 to the power of infinity. So all these are called indeterminate forms. Indeterminate forms. When we are applying the limits or when we are solving some problems, it appears it takes the form of indeterminates. In that time, we are using some other methods to solve that type of problems. Okay. As here, so let us consider what is an indeterminate form is. As here, when f of x and g of x are two functions, so that are defined over the interval ab, and satisfies Cauchy's theorem. You know that what is Cauchy's theorem is. You know that what is Cauchy's theorem? What Cauchy's theorem says? Cauchy's theorem says that when f of x and g of x are two functions, The two functions are continuous, the two are continuous functions, and they are continuous in the interval ab, differentiable in the interval ab, and that g dash of x is not equal to 0 anywhere in ab. Okay, so that same concepts here, f of x and g of x, so that f of x and g of x, two functions satisfying the conditions of Cauchy's theorem, they satisfy Cauchy's theorem. So in that time, the limit of f of x by g of x when x tends to a is same as limit of f of x by limit of g of x. Yes, you know that. So this is a familiar property of the limits. Okay, so limits numerator one function is a denominator one function is andre separate agi numerator function denominator function ge separate limits na apply ಮಾಡ್ಕೋಬಹುದು ಅಂತ ಅರ್ಥ. Okay, so provided both limits exists and g of x, that limit of the denominator is not equal to 0. 0 ಇರಬಾರ್ದು, ಯಾಕೆ ಇರಬಾರ್ದು ಅಂದರೆ 0 ಬಂದರೆ ಏನಾಗುತ್ತೆ, ಇನ್ಫಿನಿಟಿ ಆಗುತ್ತೆ. ಸೊ ಲಿಮಿಟ್ ಆಫ್ g of x is not equal to 0. So if limit of f of x is 0 and limit of g of x is 0, so if limit of f of x is 0, this numerator limit is 0 and denominator limit is also 0. So then we call this expression f of x by g of x is, we say that it assumes the indeterminate form. It takes indeterminate forms anta heltivi. So 0 by 0 as x tends to a. So other indeterminate forms are, I already told you that other indeterminate forms are infinity by infinity, 0 into infinity, infinity minus infinity, 0 to the infinity, 1 to the power of infinity, and infinity to the power of 0. All these are indeterminate forms. Some samples of some of the indeterminate forms are given here. Okay, yes, is that any new method when it assumes indeterminate form? When we are evaluating limits, limit find out ಮಾಡಬೇಕಾದ್ರೆ indeterminate form ಅಂದ್ರೆ ಬೇರೆ ಮೆಥಡ್ಸ್, ಈಗ ನಾವು ಆಲ್ರೆಡಿ ಅದು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿಕೊಂಡು ಫ್ಯಾಕ್ಟರೈಸ್ ಮಾಡಿ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿ ಅದು ಮಾಡಿದ್ವಿ ಅಲ್ಲ, ಅದನ್ನ ಬಿಟ್ಟು ಬೇರೆ ಏನಾದರೂ ಮೆಥಡ್ಸ್ ಇದೆಯಾ ಅಂದರೆ ಎಸ್, ದೆರ್ ಇಸ್ ಅ ಮೆಥಡ್. So when it assumes indeterminate forms, 0 by 0, 0 by 0 ಇದ್ರೆ ಒಂದು ಮೆಥಡ್ ಇದೆ, ಅದು ಯಾವುದು ಅಂತಂದ್ರೆ that method is, that is the L'Hospital rule. L'Hospital rule, we call it as an L'Hospital rule. So let us see what that L'Hospital rule says. ಏನು ಹೇಳುತ್ತೆ ಅದು L'Hospital rule ಏನು ಹೇಳುತ್ತೆ ನೋಡೋಣ. So when it is 0 by 0 form, so this is the L'Hospital rule. I write that as in the form of theorem. Okay, let the functions f of x and g of x defined on some interval. Some interval is not specifically defined. ಎಲ್ಲೋ ಯಾವುದಾದ್ರೂ ಒಂದು ಇಂಟರ್ವಲ್ ಆಗಿರ್ಬೋದು. Some interval the satisfy the Cauchy's theorem, and also f of a is equal to 0 and g of a is equal to 0. In that time, limit of f of x by g of x when x tends to a is same as limit of f dash of x by g dash of x, provided the latter limit exists. ಅಂದರೆ ಏನರ್ಥ ಇದ್ರದ್ದು ಅಂತಂದರೆ f of x by g of x ನ ಲಿಮಿಟ್ಟು ಮತ್ತೆ ಅದನ್ನ ನ್ಯೂಮರೇಟರ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಿ ಡಿನಾಮಿನೇಟರ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಿ ಅಪ್ಲೈ ಮಾಡೋ ಲಿಮಿಟ್ ಎರಡು ಒಂದೇ ಇರುತ್ತೆ. ಯಾವಾಗ f of a is equal to 0, g of a is equal to 0 ಆಗಿದ್ದಾಗ ಅಂತ L'Hospital rule ಹೇಳುತ್ತೆ. Okay, so is that any proof for this? Yes, proof ಇದೆ. So you see, this is the proof of this theorem. So consider functions f of x and g of x, they are defined in any interval. ಯಾವುದೋ ಒಂದು ಇಂಟರ್ವಲ್ ಹೇಳಿದ್ದಾರೆ. So we consider an arbitrary interval. ನಾವು ಒಂದು arbitrary interval ತಗೋಣ, that is alpha beta, and x is the value not equal to a, be some point in alpha beta. So let x is not equal to a, be some point in alpha beta. Now by Cauchy's formula, what is that Cauchy's formula says that Cauchy's formula ಗೊತ್ತಿದೆ ನಿಮಗೆ, f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a ಅಂತ ಇದೆಯಲ್ಲ ಅದು. Okay, so we are using the same Cauchy's formula here, f of x minus f of a by g of x minus g of a. So what that x is and what is the value of a? Yes, here we say that x is not equal to a, ಎರಡು ಈಕ್ವಲ್ ಆಗಂಗಿಲ್ಲ x ಮತ್ತೆ a. Okay, be some point in alpha beta, ಅದೆಲ್ಲಿರುತ್ತೆ, ಆಲ್ಫಾ ಬೀಟಾ ಇಂಟರ್ವಲ್ ಅಲ್ಲೇ ಇರುತ್ತೆ. x is the point which is not equal to a ಗೆ ಈಕ್ವಲ್ ಆಗಲ್ಲ, ಆಲ್ಫಾ ಬೀಟಾ ಮಧ್ಯದಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ಬೈ ಕೌಚಿಸ್ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ? ಸೊ ವಿ ಕ್ಯಾನ್ ರೈಟ್ ದಟ್ ಕೌಚಿಸ್ ಫಾರ್ಮುಲಾ ಇನ್ ದಿಸ್ ಫಾರ್ಮ್. ಹೇಗೆ ಬರಿಬೋದು ಅಂತಂದರೆ ಕೌಚಿಸ್ ಫಾರ್ಮುಲಾ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಮೈನಸ್ ಎಫ್ ಆಫ್ ಎ ಬೈ ಜಿ ಆಫ್ ಎಕ್ಸ್ ಮೈನಸ್ ಜಿ ಆಫ್. ಇಲ್ಲಿ ಪರ್ಟಿಕ್ಯುಲರ್ ಇಂಟರ್ವಲ್ ಏನು ಕೊಟ್ಟಿಲ್ಲ, ಆಲ್ಫಾ ಬೀಟಾ ಅಂತ ತೊಗೊಂಡಿದ್ದೀವಿ ಅಲ್ವಾ. ಆ್ಯಂಡ್ ಎಕ್ಸ್ ಆ್ಯಂಡ್ ಎ ಆರ್ ದ ವ್ಯಾಲ್ಯೂಸ್, ದೇ ಆರ್ ನಾಟ್ ಸೇಮ್ ಬಟ್ ದೇ ಆರ್ ಇನ್ ಬಿಟ್ವೀನ್ ಆಲ್ಫಾ ಬೀಟಾ ಒಳಗಡೆ ಇದ್ದಾವೆ. ಸೊ ನೀವು ಅದಕ್ಕೆ ಕೌಚಿಸ್ ಥಿಯರಮ್ನ ಅಪ್ಲೈ ಮಾಡ್ಕೋಬೋದು. ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ? ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಮೈನಸ್ ಎಫ್ ಆಫ್ ಎ ಬೈ ಜಿ ಆಫ್ ಎಕ್ಸ್ ಮೈನಸ್ ಜಿ ಆಫ್ ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ ಬೈ ಜಿ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ. ವಾಟ್ ಈಸ್ ದಟ್ ಸಿ? ಸಿ ಇಸ್ ದ ವ್ಯಾಲ್ಯೂ ದಟ್ ಲೈಸ್ ಬಿಟ್ವೀನ್ ಎ ಆ್ಯಂಡ್ ಎಕ್ಸ್. ಇಲ್ಲಿ ಏನಾಗಿದೆ ಅಂದರೆ ನಾವು ಒಂದು ಆರ್ಬಿಟ್ರರಿ ಇಂಟರ್ವಲ್ ತಗೊಂಡ್ವಿ, ಯಾವುದೋ ಒಂದು ಇಂಟರ್ವಲ್ ಆಲ್ಫಾ ಬೀಟಾ ಅಂತ ತಗೊಂಡ್ವಿ. ಓಕೆ, so in this interval we consider a point a is any fixed point here and x ಎಲ್ಲಾದರೂ ತಗೋಬೋದು ನೀವು ಇಂಟರ್ವಲ್ ಒಳಗಡೆ, ಇದ್ರೊಳಗಡೆ ಎಲ್ಲಿ ಬೇಕಾದ್ರೂ ತಗೊಳ್ಳಿ ಇಲ್ಲಿ. ಓಕೆ, ಸೊ ಬಟ್ ದೇ ಆರ್ ನಾಟ್ ಸೇಮ್, ಎರಡು ಈಕ್ವಲ್ ಆಗಬಾರ್ದು. ಎಕ್ಸ್ ಮತ್ತು ಎ ಎರಡು ಈಕ್ವಲ್ ಆಗಬಾರ್ದು. ಸೊ ಟೇಕ್ ಸಮ್ ಎಕ್ಸ್ ಇಸ್ ಇಯರ್, ಎಕ್ಸ್ ಇದೆ ಅಂತಾನೆ ಇಟ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ಎಕ್ಸ್ ಇಸ್ ದ ಪಾಯಿಂಟ್ ಇಯರ್. ಸೊ ದೆನ್ if you apply the Cauchy's theorem, ಹೀಗೆ ಕಾಣಿಸುತ್ತೆ. ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಮೈನಸ್ ಎಫ್ ಆಫ್ ಎ, ಎಫ್ ಆಫ್ ಬಿ ಮೈನಸ್ ಎಫ್ ಆಫ್ ಎ ಬರೀತಿದ್ವಿ. ಇಯರ್ ಯು ಟೇಕ್ ಇದೇ ಇಂಟರ್ವಲ್ Cauchy's theorem ಅಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಳಿ. ಎ ಎಕ್ಸಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ? ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಮೈನಸ್ ಎಫ್ ಆಫ್ ಎ ಬೈ ಜಿ ಆಫ್ ಎಕ್ಸ್ ಮೈನಸ್ ಜಿ ಆಫ್ ಎ. ಸೊ ಹಾಗಾದರೆ ಈ ಕಂಡೀಷನ್ Cauchy's theoremನ ಎ ಎಕ್ಸಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡೋದಾದರೆ ಸಿ ಎಲ್ಲಿರುತ್ತೆ? ಎ ಎಕ್ಸ್ ಮಧ್ಯದಲ್ಲಿರುತ್ತೆ. ಸಿ ಇಸ್ ದ ವ್ಯಾಲ್ಯೂ, ಇಟ್ ಈಸ್ ಇನ್ ಬಿಟ್ವೀನ್ ಎ ಆ್ಯಂಡ್ ಎಕ್ಸ್. ಸೊ ನಾವು what is f of a? f of a ಅಂದರೆ ಏನು? ಸೊ ದೇ ಆರ್ ಗಿವನ್ ದಟ್ ಎಫ್ ಆಫ್ ಎ 0. ಥಿಯರಮಲ್ಲಿ ಹೇಳಿದ್ದಾರೆ ಎಫ್ ಆಫ್ ಎ 0 ಅಂತ. ಸೊ ಮತ್ತು ಜಿ ಆಫ್ ಎ ಏನಾಗುತ್ತೆ? ಅದನ್ನು 0 ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಎಫ್ ಆಫ್ ಎ ಜಿ ಆಫ್ ಎ ಎರಡು 0 ಆದರೆ ಏನಾಯಿತು? ಇಲ್ಲಿ 0 ಹಾಕೋಣ, ಇದು 0 ಹಾಕೋಣ. ಸೊ ದೆನ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಬೈ ಜಿ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ ಬೈ ಜಿ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ ಆಯಿತು. ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಬೈ ಜಿ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ ಬೈ ಜಿ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ. ದೇ ಆರ್ ಸೇಮ್ ಅಂತ ಅರ್ಥ. f of x by g of x is same as f dash of c by g dash of c. Allah, according to when we are applying the conditions and Cauchy's theorem, we are getting this result. So ನಮಗೆ ಸುಮ್ಮನೆ ಬಂದಿಲ್ಲ ಅದು, Cauchy's theorem ಅಪ್ಲೈ ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ ಬಂದಿದೆ ಅದು. ಓಕೆ, ಸೊ ನಾವು c is lies between a and x. ನಾನು ಆವಾಗಲೇ ಹೇಳಿದೆ c is the value that lies between a and x. a x ಮಧ್ಯದಲ್ಲಿದೆ. Yes, in diagram also I am writing that c is the value in between a and x. Okay, so now a and x, c tends to a when x tends to a. c tends to a when x tends to a. Just a minute. c tends to a when x tends to a. ಸೊ ಇಲ್ಲಿ ಎಕ್ಸ್ನ ವೆನ್ ಎಕ್ಸ್ ಟೆಂಡ್ಸ್ ಟು ಎ ಅಂತ ಬರ್ಕೊಂಡ್ರೆ, ಸೊ ದೆನ್ ಸಿ ಏನಾಗುತ್ತೆ? ನೀವು ಎಕ್ಸ್ನ ಈ ಕಡೆ ಮೂವ್ ಮಾಡ್ತಿದ್ಯಾ ಅಂತ ಅರ್ಥ. ಎಕ್ಸ್ ಈ ಕಡೆ ಬಂದರೆ ಸಿ ಎಲ್ಲಿರಬೇಕು? ಎ ಮತ್ತು ಎಕ್ಸ್ ಮಧ್ಯದಲ್ಲೇ ಇರಬೇಕು. ಸೊ ಎಕ್ಸ್ನ ಎಲ್ಲಿಗೆ ತೊಗೊಂಡು ಬಂದರೆ ಸಿ ಅದ್ರ ಮಧ್ಯದಲ್ಲೇ ಇರಬೇಕು ಅಂದರೆ ಸಿ ಕೂಡ ಈ ಕಡೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. ಅಂದರೆ ನೀನು ವೆನ್ ಯು ಆರ್ ಟೇಕಿಂಗ್ ದ ವ್ಯಾಲ್ಯೂ ವಿಚ್ ಈಸ್ ವೆರಿ ಕ್ಲೋಸೆಸ್ಟ್ ಟು ಎ, ದೆನ್ ಸಿ ಈಸ್ ಆಲ್ಸೋ ದ ವ್ಯಾಲ್ಯೂ ವಿಚ್ ಈಸ್ ಮೂವ್ಸ್ ಟುವರ್ಡ್ಸ್ ಎ. ಸೊ x tends to a means c tends to a. When x tends to a, so in that time c tends to a. So ಈಗೇನು ಮಾಡ್ಬೋದು ಹಾಗಾದರೆ? ಸೊ ಲಿಮಿಟ್ ಆಫ್ ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಎಕ್ಸ್ ಬೈ ಜಿ ಡ್ಯಾಶ್ ಆಫ್ ಎಕ್ಸ್ ವೆನ್ ಎಕ್ಸ್ ಟೆಂಡ್ಸ್ ಟು ಎ is L, then limit of f dash of c by g dash of c when x tends to a is also L. ಅದು ಕೂಡ L ಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ಸೊ ಎರಡು ಈಕ್ವಲ್ ಆಗೋದಾದರೆ, so we know that f of x by g of x is same as f dash of c by g dash of c. To that one you apply the limit x tends to a. So and to f dash of c by g dash of c, since x tends to a is same as c tends to a ಆಗಿರುತ್ತೆ ಅನ್ನೋದಾದರೆ, ಸೊ ನೀವು ಇದಕ್ಕೆ ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ ಬೈ ಜಿ ಡ್ಯಾಶ್ ಆಫ್ ಸಿಗೆ ಸಿ ಟೆಂಡ್ಸ್ ಟು ಎ ಅಂತ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು, ಬಿಕಾಸ್ ಬೋತ್ ಲಿಮಿಟ್ಸ್ ಆರ್ ಸೇಮ್. ಸೊ ದೆನ್ ವಿ ಸೇ ದಟ್ ಸಿ ಜಾಗದಲ್ಲಿ ಎಕ್ಸ್ ಹಾಕಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಎಕ್ಸ್ ಬೈ ಜಿ ಡ್ಯಾಶ್ ಆಫ್ ಎಕ್ಸ್ ವೆನ್ ಎಕ್ಸ್ ಟೆಂಡ್ಸ್ ಟು ಎ ಆಗುತ್ತೆ. ಸಿ ಜಾಗದಲ್ಲಿ ಎಕ್ಸ್ ಹಾಕ್ಬೋದು, ಏನು ತೊಂದರೆ ಇಲ್ಲ. ಓಕೆ, ಸೊ ಫೈನಲಿ ವಿ ರೈಟ್ ದಟ್ limit of f of x by g of x when x tends to a is equal to limit of f dash of x by g dash of x. So totally we conclude that when it appears indeterminate form, when we are applying a limit, so when we apply the limit, it appears in indeterminate forms. It takes indeterminate form. In that time we can apply the L'Hospital rule. L'Hospital rule ಏನು ಹೇಳುತ್ತೆ, ಆ ನ್ಯೂಮರೇಟರ್ ಫಂಕ್ಷನ್ ಅನ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡೋ, ಡಿನಾಮಿನೇಟರ್ ಫಂಕ್ಷನ್ ಅನ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡೋ, ಆಮೇಲೆ ಇನ್ನೊಂದ್ಸತಿ ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡೋ. ಹಿಯರ್ ದ ಕ್ವಶನ್ ಇಸ್ ಒನ್ಸ್ ಅಗೇನ್ ಅದು ಲಿಮಿಟ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಿ ಲಿಮಿಟ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ ಮೇಲೇನು, ಸೊ ಅವಾಗಲೇ ನಾವು ಯಾವುದೋ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದ್ವಿ. ಯಾವುದೋ ಲಿಮಿಟ್ ಆಫ್ x square minus 9 by x minus 3 x tends to 3 ಅಂತ. ಸೊ ವೆನ್ ವಿ ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ ದ ಲಿಮಿಟ್ ಅವಾಗಲೇ ಹೇಳಿದೆ ನಾನು 0/0 ಬಂತು ಅಂತ. L'Hospital ರೂಲ್ ಏನು ಹೇಳ್ತಾ ಇದಕ್ಕೆ, ನೀನು ಏನು ಮಾಡೋ, ಈ ನ್ಯೂಮರೇಟರ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡೋ 2x, ಡಿನಾಮಿನೇಟರ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಿ. ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಆಫ್ x minus 3 is 1. ಸೊ ಈಗ ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡೋ. ಸೊ ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ 2 into 3 is equal to 6. We get the same result there also. ಅವಾಗಲೂ ನಾವು ಸಾಲ್ವ್ ಮಾಡಿದಾಗ 6 ಬಂದಿದೆ ಅಲ್ವಾ. ಸೊ ವೆನ್ ಯು ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ ದ L'Hospital ರೂಲ್ ವಿ ಆರ್ ಗೆಟಿಂಗ್ 6 ಓನ್ಲಿ. ಅವಾಗಲೂ ಕೂಡ ಇವಾಗಲೂ ಕೂಡ ನಮಗೆ 6 ಬರ್ತಾ ಇದೆ. ಸೊ ಅಂತಂದರೆ ವಿ ಕ್ಯಾನ್ ಅಪ್ಲೈ ದ L'Hospital. ಹಿಯರ್ ಮೈ ಕ್ವಶನ್ ಈಸ್, ಈಗ ನಾವು L'Hospital ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ. ಆಫ್ಟರ್ ಅಪ್ಲೈಯಿಂಗ್ L'Hospital ರೂಲ್ ಒನ್ ಟೈಮ್, ಒನ್ಸ್ ಅಗೇನ್ ಇಟ್ ಟೇಕ್ಸ್ ಇಂಡಿಟರ್ಮಿನೇಟ್ ಫಾರ್ಮ್, ಮತ್ತೆ 0/0ನೇ ಬರ್ತಾ ಇದೆ ಅಂದರೆ ಏನು ಮಾಡಬೇಕು, ಒನ್ಸ್ ಅಗೇನ್ ಅಪ್ಲೈ ದ L'Hospital ರೂಲ್, ಮತ್ತೆ ಅದನ್ನೇ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ದ ಎಬೋ ಥಿಯರಮ್ ಕ್ಯಾನ್ ಬಿ ಜನರಲೈಸ್ಡ್ ಇಫ್ f dash of a is 0, g dash of a is also 0, and the derivatives f dash of x, g dash of x satisfy conditions that mentioned in the theorem. That means they are satisfying Cauchy's theorem on f of x and g of x. Then apply LH rule, that means L'Hospital rule to f dash of x, g dash of x. ಮತ್ತೆ ಒನ್ಸ್ ಅಗೇನ್ ಅದನ್ನು ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು. f double dash of x ಬರುತ್ತೆ, g double dash of x ಬರುತ್ತೆ, ಅಂಡ್ ಟು ದಟ್ ಒನ್ ಯು ಅಪ್ಲೈ ದ ಲಿಮಿಟ್. ಮತ್ತೆ 0/0 ಬಂತು, ಮತ್ತೆ L'Hospital ರೂಲ್ ಉಂಟು. ಸೊ ಎಲ್ಲಿವರೆಗೆ ನಮಗೆ 0/0 ಬರೋದಿಲ್ಲ ಅಲ್ಲಿವರೆಗೆ ಸೊ ಯು ಕ್ಯಾನ್ ಅಪ್ಲೈ ದ L'Hospital ರೂಲ್. ಮತ್ತೆ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡೋದು, ಲಿಮಿಟ್ಸ್ ಅಪ್ಲೈ ಮಾಡೋದು. ಸೊ 0 ಇಂಡಿಟರ್ಮಿನೇಟ್ ಫಾರ್ಮ್ ಬರಲಿಲ್ಲ ಅಂತ ಅಂದರೆ ಸ್ಟಾಪ್ ಮಾಡೋದು. ಇಂಡಿಟರ್ಮಿನೇಟ್ ಫಾರ್ಮ್ಸ್ ಬಂತು ಅಂದರೆ ಒನ್ಸ್ ಅಗೇನ್ ಅಪ್ಲೈ ದ L'Hospital ರೂಲ್. Okay, yes, so I want to discuss some more problems on this one. Yes, evaluate, as here is the problem. So evaluate limit of x by x minus sin x by x cube, x minus sin x by x cube. So to evaluate this limit, you take this function is some k, let k is equal to limit x tends to 0 x minus sin x by x cube, x minus sin x by x cube. To this you apply the limit, which is equal to, when you apply x is 0 here, 0 minus sin 0 by 0, which is equal to 0/0, is indeterminate. So if it is indeterminate, so then you apply the L'Hospital rule. So apply L'Hospital rule. Apply L'Hospital rule. So what is L'Hospital rule is, k is equal to L'Hospital rule ಅಂದ್ರೆ ನೀವು quotient rule ಅಪ್ಲೈ ಮಾಡಬಾರ್ದಿಲ್ಲ. ಡೋಂಟ್ ಅಪ್ಲೈ quotient rule here to differentiate this. So ಏನು ಮಾಡಬೇಕು, ಈ ಸಪ್ರೇಟ್ಲಿ ಯು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ನ್ಯೂಮರೇಟರ್ ಅಂಡ್ ಡಿನಾಮಿನೇಟರ್. ಲಿಮಿಟ್ x tends to 0. What is the differentiation of x? It is 1 minus differentiation of sin x is cos x by, so differentiation of x cube is 3x square. Okay, so now you apply the limit. So ಈಗ ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ, so what it gives, which is equal to 1 minus cos 0 by 0, which is equal to 1 minus 1 by 0. 1 minus 1 is 0 by 0. Again it assumes indeterminate form is indeterminate. So if it takes indeterminate form, next to take, again apply L'Hospital rule. Apply L'Hospital rule. So then k is equal to limit x tends to 0. ಮತ್ತೆ ಏನು ಮಾಡಬೇಕು? ಮತ್ತೆ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಬೇಕು. Differentiation of 1 is 0 minus differentiation of cos x is minus sin x. This divided by 3 into differentiation of x square is 2x. Differentiation of x square is 2x. Now, which is equal to limit x tends to 0. This is sin x by 6x. So one method is you can apply the limit to this one. Otherwise, you write this is, you can take constant outside 1 by 6 into limit x tends to 0 sin x by x. So I hope you know this standard limit. Limit of sin x by x tends to 0 is equal to 1. You should remember some of the standard results. Limit of sin x by x when x tends to 0 is equal to 1. So limit of tan x by x when x tends to 0 is equal to 1. Cos x by x alla adu baradilla. So it is for sin and tan only. So limit of sin x by x when x tends to 0 is 1. Limit of tan x by x when x tends to 0, that is 1. Now this becomes 1 by 6 into its limit value is 1, which is equal to 1 by 6. Standard formula apply ಮಾಡೋಕೆ ಇಷ್ಟ ಇಲ್ಲ ಅಂದರೆ ಏನು ಮಾಡ್ಬೋದು, once again apply the L'Hospital rule. L'Hospital rule apply ಮಾಡ್ಕೊಂಡು ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ಪಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ಕೋಬೋದು. ಸೊ ಫಾರ್ಮುಲಾ ಬೇಡ ಅನ್ನೋದಾದರೆ. And similarly, evaluate one more problem is tan x minus x by x square tan x. You take let k is equal to tan x minus x by x square into tan x. As I already told you that limit of tan x by x when x tends to 0 is equal to 1. ಹಾಗೇನೆ ಇದು ರೆಸಿಪ್ರೋಕಲ್ ತಗೊಂಡ್ರೆ, so if you take it is limit of okay, so now you use that formula here. K is equal to, yes, what is that? X tends to 0, limit x tends to 0. Okay, K is equal to limit x tends to 0. You take this is tan x minus x by x square into limit x tends to 0. This is 1 by, here you do one thing. So tan x is there here, tan x ಇದೆ ಆಲ್ರೆಡಿ ಇಲ್ಲಿ ಅಲ್ವಾ. ಸೊ ಇದಕ್ಕೆ ಏನು ಮಾಡಿ ಅಂದರೆ, in denominator you take 1 tan x. If you are adding x here, you have to add one more x here. ಯಾಕೆಂದರೆ x ಕ್ಯಾನ್ಸಲ್ ಆದರೆ ಮತ್ತೆ tan x ಬರುತ್ತೆ. ಓಕೆ, ಸೊ ಮಲ್ಟಿಪ್ಲೈ ಅಂಡ್ ಡಿವೈಡ್ x in the denominator. Multiply and divide in x by in the denominator. So now its value is idenaitu 1 aitu. 1 by 1 means it is 1 only. So now k can be written as k is equal to limit x tends to 0. This is tan x minus x by x square into x is x cube, and its limit is 1. It's not necessary to write that 1 into this. Okay, so this x cube. So to this one you apply the limit now. ಇದಕ್ಕೆ ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡಿ ಈಗ. ಸೊ ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು tan 0 is what? Tan 0 is 0 by 0. So tan 0 is 0. So it is 0 by 0. 0 by 0 is indeterminate. So 0 by 0 is indeterminate. sorry, it is indeterminate. It is indeterminate. So now you take that, and now you apply L'Hospital rule. So apply L'Hospital rule. So according to L'Hospital rule, you differentiate numerator and differentiate denominator separately, and after that you apply the limit. Limit extends to 0. Differentiation of tan x is secant square x minus differentiation of x is 1 divided by differentiation of x cube 3x square. So one thing, you apply the limit apply ಮಾಡಿಕೊಂಡು ಮತ್ತೆ L'Hospital rule apply ಮಾಡ್ಬೋದು. ಇಲ್ಲ ಅಂತಂದ್ರೆ otherwise you can simplify this one. ಏನು simplification ಮಾಡ್ಬೋದು ಅಂದ್ರೆ ಇಲ್ಲಿ, here you know that 1 plus tan square theta is equal to secant square theta. So tan square theta can be written as secant square theta minus 1. Tan square theta is equal to secant square theta minus 1. So in place of secant square x minus 1, you can write it is tan square x. ಇದನ್ನ ಏನು ಮಾಡಬಹುದು ಅಂದ್ರೆ ನೀವು, you write this is limit extends to 0. You can write this is tan square x by 3x square. Tan square x by 3x square. So okay, so tan square theta is equal to secant square theta minus 1. So it is tan square, you can write secant square x minus 1 is tan square x. ಇಲ್ಲಿ ಏನು ಮಾಡ್ಬೋದು ಅಂದರೆ ನೀವು, which is equal to, you can write which is equal to limit extends to 0. Limit extends to 0. So this can be written as 1 by 3 into or you write this is, so ಇದು ಹೇಗೆ ಬರೀಬೋದು ಅಂದರೆ ಇದು, so you can take this 1 by 3 outside from the limit ಇಂದ ಹೊರಗೆ ಇಟ್ಕೊಂಡ್ಬಿಡಿ 1 by 3 ನ. So then it is 1 by 3 into limit extends to 0. This is tan x by x, tan square x by x square. Tan square x by x square. So which is equal to, ನಿಮಗೆ ಇನ್ನೂ ಕ್ಲಾರಿಟಿ ಬೇಕು ಅಂದರೆ, you can write it is 1 by 3 into limit extends to 0. This is tan x by x whole square. So what is the limit? Limit of tan x by x when x tends to 0? It is 1. So this becomes 1 into 1 square. 1 square means it is 1. It is 1 by 3 into 1 is equal to 1 by 3. So that is the value of the limit. K is equal to 1 by 3. So therefore K is equal to 1 by 3. So similarly, one more example. So evaluate limit of x tends to b, x to the power b minus b to the power of x by x to the power of x by x to the power of x minus b to the power of b. So its limit is limit extends to b here. Limit extends to b. So to solve this, you take let k is equal to, let k is equal to limit extends to b, it is x to the power b minus b to the power of x by x to the power of x minus b to the power of b, which is equal to, so apply the limit first. K is equal to, put x is equal to b here, So wherever x is there, you write that x is b. It is b to the power b by b to the power b minus b to the power b. As all of you know that it is 0 by 0. Yes, is indeterminate. Is indeterminate. So it is an indeterminate form. So when it assumes indeterminate form, we have to take, when it assumes indeterminate form, you apply the L'Hospital rule. Apply L'Hospital rule here. Apply L'Hospital rule. So then k is equal to, yeah, you have to differentiate this. X tends to b. What is the differentiation of x to the power b? X to the power b is like x to the power n. Differentiation of x to the power of n is nx to the power n minus 1. Similarly, its differentiation gives that b into x to the power b minus 1 minus, so it is like x to the power n. Okay, so what is the differentiation of a to the power of x? Differentiation of a to the power of x is a to the power of x into log a, right? So you should remember that formulas. It is b to the power of x into log b divided by denominator x to the power of x is there. What is the differentiation of x to the power of x? So we can find its differentiation by taking log. Y is equal to x to the power of x. You take and take log on both sides. It is x log x. Differentiation of x log x is x into 1 by x plus log x into 1. So that is 1 plus log x. So like that you find its value. Okay. So write its value. Write its value directly. It is x to the power of x into 1 plus log x. Differentiation of x to the power of x is equal to x to the power of x into 1 plus log x. Let's use that formula directly. So it is x to the power of x into 1 plus log x minus b to the power of b. Both are constants b. So its differentiation is 0. Okay, to this one you apply the limits. Idhukku limit apply madana. So now k is equal to b into b to the power b minus 1 minus b to the power b into log b. This divided by b to the power b into 1 plus log b. Isn't it? So then calculate its value. So it is b and b. You can multiply that b's. Okay. Multiply madadre ಏನು ಬರುತ್ತೆ? So then it gives that b to the power 1 plus b minus 1 minus b to the power b into log b. This divided by b to the power b into 1 plus log b. Again, in numerator, this becomes b to the power b. 1 ಮತ್ತೆ 1 cancel ಆದರೆ ಏನು ಉಳಿಯುತ್ತೆ? b to the power b ಇದೆ. You can take b to the power b is a common factor. So take b to the power b is a common factor. Then it is 1 minus log b divided by this is b to the power b into 1 plus log b. So in both numerator and denominator you cancel b to the power b. So finally we have the limit value is 1 minus log b by 1 plus log b. 1 minus log b by 1 plus log b. So like this you can apply the L'Hospital rule and find its values. Value of the limit. One more limit problem is here. It is the limit x tends to 0 e to the x minus e to the minus x minus 2x by x square sin x. So it is take let k is equal to limit x tends to 0 e to the x minus e to the minus x minus 2x by x square into sin x. So whether it is sin x or cos x are there in the denominators, first you eliminate that sin and cos by using limit of sin x by cos x when x tends to 0 is equal to 1. So use the same formula and try to avoid it. First sin ಮತ್ತೆ cos denominator ಇಂದ cancel ಆಗೋ ತರ ನೋಡ್ಕೊಳ್ಳಿ. ಏನು ಮಾಡ್ಬೋದು ನಾವಿಲ್ಲಿ? So x tends to 0, it is e power x minus e power minus x minus 2x by ಇಲ್ಲಿ ಏನು ಮಾಡಿ ಇದು x square ಬರ್ಕೊಳ್ಳಿ and separately apply the limit to this limit 1 by sin x by x. Limit 1 by sin x by x. ಇಲ್ಲಿ x ಹಾಕಿದ್ದೀರಾ ಅಂದರೆ ಇಲ್ಲಿ ಇನ್ನೊಂದು extra x ಹಾಕಬೇಕು. Okay. So this limit x tends to 0. Its limit becomes 1. 1 by 1 is 1. Okay. So which is equal to limit x tends to 0. This is e power x minus e power minus x minus 2x divided by x square into x is x cube, which is equal to, you apply the limit now, it is e power 0 minus e power 0 minus 2 into 0 by 0. Yes, this is clearly, this is 1 minus 1, 1 minus 1 is 0, 0 minus 0, it is 0 by 0, is indeterminate. Is indeterminate form. Okay, if it takes indeterminate form, in that time you apply the L'Hospital rule. Apply L'Hospital rule to this one. Apply L'Hospital rule. L'Hospital's rule here. So then we have k is equal to limit x tends to 0 as differentiation of e power x is e power x minus differentiation of e power minus x is minus e power minus x minus differentiation of 2x is 2 divided by differentiation of x cube is 3x square. So apply the limit to this one, which is equal to, apply ಮಾಡೋಣ e power 0 minus of minus it plus ಆಗುತ್ತೆ. So plus e power minus 0 minus 2 divided by 0. So this is 1 plus 1 is 2. 2 minus 2 by 0, that is 0 by 0, is indeterminate form. So it takes indeterminate form. Again you apply L'Hospital rule. Apply L'Hospital rule. Apply L'Hospital's rule. So then we have k is equal to limit x tends to 0. So e power x, differentiation is e power x minus of minus becomes plus. Again differentiation of e power minus x is minus e power minus x minus differentiation of constant is 0. This divided by 3 into differentiation of x square is 2x. Simplifying this, limit x tends to 0 e power x minus e power minus x divided by 6x. You apply the limit, ಮತ್ತೆ limit apply ಮಾಡಿ ಇದಕ್ಕೆ, this is equal to e power 0 minus e power 0 by 0, which is equal to 1 minus 1 by 0, which is equal to 0 by 0, is indeterminate. So again apply L'Hospital rule. Applying L'Hospital rule. So then k is equal to limit x tends to 0. So differentiation of e power x minus differentiation of e power minus x is minus e power minus x divided by differentiation of 6x is 6, which is equal to limit x tends to 0. This is e power x plus e power minus x by 6. ಇದಕ್ಕೆ ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ e power 0 plus e power minus 0 by 6 which is equal to, so e power 0 means 1, e power minus 0 is also 1 by 6 which is equal to 2 by 6 is equal to 1 by 3. So therefore the limit value k is equal to 1 by 3. So like this we can evaluate the limits. So okay, I want to stop this session. So next session I discuss some more problems. If possible, you try to solve this one, x minus log of 1 plus x by 1 minus cos x problem. Okay, so I continue next session. Thank you.